Okay, another sample problem. This one's sample problem 1.5 from the lecture notes if you're following along with them. But it's certainly, you don't need to. You can just watch these videos. You'll have everything you need. This one has to do with an optical fiber that we're going to stretch between two major world cities, that is Paris and New York. There's a distance of 8.84 times 10 to the third kilometers between these two cities. And of course, if I'm going to convert that into an actual number, what would I have? I have to move the decimal place 3 spots to the right. So that's 8,840 kilometers is the distance between these two cities. And we're stretching this optical fiber. The optical fiber has a weight of 1.19 times 10 to the minus 3 pounds per meter. So it doesn't weigh much for 1 meter. But what we want to know is what is the mass in kilograms of 6 of these strands? Not 1, but 6, if we stretch it from New York all the way to Paris. Okay? So how in the world are we going to approach this particular problem, right? Now, to this point, I've been kind of working the mathematical framework of this conversion factor business and how to solve these problems. And I certainly want everybody to get good at that, okay? But, you know, this particular problem has made me, again, reflect upon, okay, where could you get confused and where could you get hung up? And I think another place you can get hung up in these types of problems is really struggling with coming up with a strategy for how to solve the problem. So maybe you can kind of do the mathematics in terms of like where to put the numbers and punching them in your calculator, right? But you might struggle with coming up with a plan or a strategy how to attack the problem. And that does take a little bit of practice, I think. So if you struggle with that, maybe we can get together, talk about it some. You know, you can ask your SI leader about it. Or else you can just practice working a lot of these problems and hopefully it'll become more second nature to you. It does get kind of confusing sometimes because you might look at a problem, there might be all these different numbers, you know, 2, 3, 4 different numbers. Some of the times they're even distractors. They have nothing to do with solving the problem. So you have to kind of, you get very confused as, okay, well, where do I start? Like, how do I get at the information I want? And you have to kind of come up with a good internal filter, I think, within your brain to help you with that. All right, so for this particular problem, the number that I noticed first, well, both of these really, is this distance between the two cities, and then the weight per meter of the optical fiber strand. And I said, okay, well, this is per meter, and this is how far it is. This is my distance. It seems like maybe I could put these numbers together if I'm using the right units and figure out what the mass of one of the strands would be from Paris to New York. And then after that, since I want to know what the mass of 6 is, I can just multiply it by 6, and that should give me a pretty good mass value or estimate, okay? So that's going to be my strategy here. So I'm going to start with the distance between these two cities, which is 8,840 kilometers, and I'm going to convert that into meters units. Now, why do I want to convert to meters units from kilometers? Because if you look closely here at the mass per distance, that has meter units attached. So I need to figure out how many meters of the cable I need so I can figure out what the mass of one of these cables is, okay? I'm going to do that in a subsequent step. So of course for every 1 kilometer, there's 1,000 meters. I put kilometers, my undesirable unit, in the denominator so it cancels. And then I just propagate through the calculation my desirable unit. So my answer then is 8.84 times 10 to the 6th meters. This is, well, no, that's not my final answer, but this is the distance, okay, between these two cities. Just converting the units into meters from kilometers, okay? Now I'm kind of making some progress here. Because now that I know the distance in meters between the two cities, I can figure out what the mass of one of these strands, these fiber optic strands, will be. Because I know from the problem that for every 1 meter of fiber optic strand, it has a mass or a weight of 1.19 times 10 to the minus third pounds. So I put meters in the denominator, pounds up in the numerator, so I'm going to convert 2 pounds here, LBS, just by doing this multiplication of my distance times my weight per meter. Okay, so hopefully you'll see that. Now if I do that, I get 1.05 times 10 to the fourth. That now is my weight. Now what is that the weight of? Well, if you follow through the math, I think you should be able to answer that. That is the weight in pounds, a little over 10,000 pounds it looks like, of one optical fiber that we could use to stretch between these two cities. Only one. Now the problem asked us, what is the mass of 6 of these fibers? Now if I know the mass of 1, I can probably figure out what the mass of 6 is. I just got to multiply, right? So instead of having 1, just multiply by 6. Because I'm talking about 6 fibers, right? And if I do that, looks like I get 6.30 times 10 to the fourth pounds. Now I'm up around 63,000 pounds. It's pretty heavy, right? So this is the mass in pounds of 6 of these strands. Now, another thing we need to consider in problems like this is it's really easy to, even if you come up with a strategy very quickly, to get on the right track but not finish the problem. It's really easy to do that. And I have to kind of challenge y'all. Are we finished with this problem? We have the mass of 6 of these, or the weight of 6 of these fibers, right? It's 6.3 times 10 to the fourth pounds. We're done. But we're not quite done, right? What did we miss? Back in the problem, they specified a very specific particular unit for us to report our answer in. Now, on a test or something, if we wanted to kind of be a little tricky, I might give you this answer as one of your choices, right? And you say, oh, I got it right, this is it, right? But it's not technically correct, unfortunately, right? Because we wanted the mass in kilograms and not in pounds. So we're going to have to do one more unit conversion here. We've got to go pounds to kilograms. So we start with what we know, 6.3 times 10 to the fourth lbs. We're going to multiply by a conversion factor. And you probably guessed it, our lbs is what we want to go away, so that's going to be in the denominator, our undesirable unit. Our kilograms are going to be our desirable unit, so we're going to put that up top, right? So now we just need a number that corresponds between these two variables. It turns out that 2.205 pounds is equivalent to a kilogram. And that type of conversion factor between English and metric, that will be given to you on the exam, okay? So you do the math on this, and it works out to 2.86 times 10 to the fourth kilogram. And that'd be our final answer. That is the mass of 6 of these strands that can stretch between Paris and New York.